All right, let's talk about something we've all been through. You write some code, you hit run, and the output, well, it just seems to have a mind of its own, right? It feels like you're not really in charge. Well, today that changes. We're handing you the keys to the kingdom. We're going to pop the hood and show you the C++ control panel, so you can take a minute of not just what your code does, but how it looks and how it thinks. So take a look at this. We've got the number 720, but it's showing up in 5 totally different ways. You've got it as a plain old integer, then as a decimal, then with a bunch of extra zeros, even in scientific notation. It's the exact same value every time, but the presentation is all over the place. This is what happens when you let the program make the decisions for you. It's messy. So, how do we fix this mess? Well, the answer is a simple but powerful concept called formatting. It's really just about you, the programmer, taking the wheel and deciding exactly how a value is going to be presented. You know, it's like a first impression. You want your program's output to look sharp, clean, and intentional, not like it just rolled out of bed. So let's start with that first impression. We're going to dive into how you can control the look and feel of everything your code puts out there. Okay, so the tools we're going to use for this job are called manipulators. And the name is perfect, right? They're special C++ functions that let you, well, manipulate how your data is displayed. Think of them as your formatting toolkit. And to open up this toolkit, you just need to include the iomanip library. It's super simple and unlocks all this power. All right, let's open up that toolkit and get our hands dirty. We're going to look at a few of the heavy hitters in here, starting with the one that's going to make all your data line up perfectly. You see this? On one side, it's a total jumble of numbers. It's a mess, hard to read, you don't know what's what. And on the other side, a perfectly organized table. Everything's lined up in these beautiful, neat columns. That incredible transformation, that's all thanks to one simple tool, the setW manipulator. So what setW, which just means set with, actually does is pretty clever. It tells the program, hey, before you print the next thing, save me a block of space, say 10 characters wide. It creates this little invisible box, or a print field. Then, it doesn't matter if your number is 1 digit or 5 digits long, it gets placed neatly inside that box, which is how you get that perfect alignment every single time. Okay, so our columns are looking great, but what about the numbers themselves? You know how sometimes you get these crazy long floating point numbers with a million digits after the decimal point? How do we tame those? Because getting that precision right is absolutely crucial, whether you're dealing with money or scientific data. Check this out. It's a perfect cause and effect demonstration. Over on the left, you see the code says set precision 5. And boom, on the right, the output is 4.9188. Then we just tweak the code to say set precision 4, and instantly the output changes to 4.919. It's like having a little dial that lets you control exactly how many decimal places you want. So simple, so powerful. All right, here's a little cheat sheet for you with the most common manipulators. We've already covered setW for getting that perfect width and set precision for taming decimals. But you've also got left and right, which let you decide if the text sits on the left or right side of that print field we talked about. And show point is really useful. It forces the decimal point and trailing zeros to show up, which is great for prices, for example. Okay, we've totally nailed down how to control the appearance of our program. Now let's switch gears and talk about controlling its brain, its logic. I mean, how does a program actually make a decision? Well, it all comes down to a different set of tools called operators. At its core, code makes decisions by comparing stuff. That's it. And to do that, we use these things called relational operators. You've probably seen them before. Is this equal to that? Is this one bigger than that one? All those basic comparisons, they are the absolute fundamental building blocks for all the smart logic your program is ever going to have. But okay, simple comparisons are great, but what if things get more complicated? What if you need to check 2 things at once, or 3 things? You can't just keep nesting if statements forever. That's where logical operators come into play. They let us chain together multiple questions into one single powerful check. First up is the AND operator, which is just 2 ampersands. Now, this one is the strict one. It requires that every single condition you give it has to be true. If even one of them is false, the whole thing is false. No exceptions. So, if you look at this code example, it's basically asking the question, is variable A equal to 10? And is variable B also equal to 10? Both have to be true. If A is 10 but B is 9, nope, the whole thing fails. Here's a great way to think about it. Imagine a video game. To unlock that super cool achievement, you need to reach level 10 and you have to have the magic key. If you're level 10 but you don't have the key, no achievement. If you have the key but you're only level 9, sorry, no achievement. You absolutely need both. That's the AND operator. Now, on the flip side, we have the OR operator, which is 2 of those vertical pipe characters. This one is way more flexible. For the OR operator to be true, you only need one of the conditions to be true. Just one is enough to make the whole thing pass. So in this piece of code, the question is different. It's asking, is A equal to 10? Or is B equal to 9? If A is 10, we're good. The whole thing is true. If B is 9, we're also good. As long as at least one of those is true, we get a green light. The perfect real-world example is paying for something at a store. The sign says you can pay with a credit card or you can pay with cash. You don't need both, right? Either one works. That's the OR operator. And finally, there's the NOT operator, which is just an exclamation point. This one is simple. It's the opposite day operator. It just flips the result. If something is true, NOT makes it false. If it's false, NOT makes it true. It just reverses the logic. So let's step back and look at what we've assembled here. We've got the tools to control how our code looks and the tools to control how it thinks. This right here, this is your control panel. It's really this simple. Manipulators control the appearance. They're like the dials and sliders on your control panel that handle all the formatting, the alignment, and the precision. And operators? They control the logic. They're the switches and the buttons that let your program make smart decisions. And when you put them both together, that's when the magic happens. These are the levers and dials that let you turn a bunch of simple instructions into a really intelligent, user-friendly application that actually looks good and behaves exactly the way you imagined it. So there you have it. You've seen the tools. You now know how to control your code's appearance and its logic. You're no longer just telling it what to do. You're telling it how to look and how to think. So the real question is, what are you going to command it to do next?